Hi students, coming to the next topic, that is a greedy method. So when compared to all algorithm approach, whatever we have so far discussed, the simplest and straightforward approach, you call it as a greedy method. This greedy method is the simplest and straightforward approach. So actually this is not an algorithm, it is just simply technique. So greedy method is a technique. You can call it as a technique. Rather than calling as an algorithm, it's better to call it as a technique. So actually what this approach will do, what the main function of this approach, actually in this approach, the decision is taken, the greedy method, the decision is taken on basis of current available information. Okay, so in the greedy method, the decision is taken on the basis of current available information, whatever the values that, whatever the information that is present at present. So the decision will be taken based on that values. So and it does not, and without worrying about the effect of current decision in future. Means it doesn't bother about the future work. So it just discuss what is the present work is going on. So a greedy method is a decision, the decision is taken on the basis of current available information without worrying about the effect of current decision in future. So it doesn't think about whether, suppose if I insert these values, it will, at present it is working, but in future it may or may not work. So it doesn't bother about that. It think about the present decision. So this technique is used to determine a feasible solution. This technique is determined to a feasible solution that may or may not be optimal. That may or may not optimal. Okay. So what is a feasible solution? What is an optimal solution? Actually, feasible solution is any subset that satisfies the given criteria. You call it as a feasible solution. Means suppose if you take an n inputs, its solution contains a subset of inputs. So whatever the n inputs you are taken, the solution contains a subset of inputs which satisfies a given condition. So if you take any subset that satisfy the condition, you call it as a feasible solution. Means in all the subsets, if any subset is satisfied, then you call it that solution, that subset is a feasible solution. What is an optimal solution? Optimal is nothing but it takes the best or most favorable solution. Best or most favorable solution. So here in the feasible solution, if any subset satisfies the condition, you can take any one. So if all the solutions stagnate, you just take any one of the solution. But in optimal, it takes only the best and the most favorable solution that is present in the objective function. So it is just like a feasible solution, but where objective function reaches its maximum or minimum value, then you call it as a optimal solution. Now let us see what are the characteristics of greedy method. Characteristics and features of greedy method. So to construct the solution in an optimal way, this algorithm maintains two sets. So the first point is to construct the solution in an optimal way. This algorithm maintains two sets. So that is one contains chosen items, one set contains chosen items means which are having the solution, chosen items, and the next other contains, another set contains rejected items. So whatever you are taking to construct a solution, if you want to construct a solution by using the grading method to make it as an optimal way, you have to select two sets. One, the selected items, and another is the rejected items. Means one gives the best and minimum value and another gives the maximum value. And the second characteristic is greedy algorithm makes good local choice in the hope that they results in optimal solution and the feasible solution. So greedy algorithm make good local choices. Means it selects the choices in the hope they result in an optimal solution or a feasible solution. So these are the features and characteristics. Now let us see the components that are present in components of greedy algorithm. So in this video, I am just giving the overview of greedy algorithm, what this greedy algorithm contains, what it mainly bases on. So it just selects the solution that thinks about the present, not about the future. It takes the best value that is related to the present value. So next, the components that are present in the greedy algorithm is, first is a candidate set. So candidate set means here a solution is created based on this set. So whatever the solution that the greedy method is creating, that is a solution is created by using the candidate set from this set. And the second point is, and the second component is a selection function. So what's the use of selection function in the greedy algorithm? So this selection function is used to choose the best candidate to be added to the solution. Means you are selecting the best subset. And next, the third component that is present is a feasibility function. So what is the use of this feasibility function? It is used to determine whether a candidate can be used to contribute the solution. So whether the candidate is used to contribute the solution is not, is decided by the feasibility function. And coming to the next, the fourth component that is present in the greedy algorithm is a objective function. So what's the use of this objective function? Actually, this is used to, objective function is used to assign a value. Just it assigns a value to a solution or a partial solution. So whether it is a partial solution or the solution, so this objective function is used to assign a value. And the next component that is a solution function. The final is a solution function. So what is the use of the solution function in the greedy algorithm? It is used to indicate whether a complete solution has been reached or not. So it's just a solution function is final decision. It is used to indicate whether a complete solution has been reached or not. That will be decided by the solution function. So these are the 5 components that are present in the greedy algorithm: a candidate set, a selection function, a feasibility function, objective function, and a solution function. Now coming to the applications that are used in the greedy algorithm. What are the areas of application? So let me write that. Areas of applications. So in which fields this greedy method is used? Actually, the greedy method is used to solve many problems. So what type of problems it is used to solve? So it is used to solve the shortest path, finding shortest path, and it is used to finding the minimum spanning tree, by using the Prim's algorithm or the Kruskal's algorithm. And the next application is job sequencing with the deadline, and fractional knapsack problems. So these are the different applications of the greedy method. So in this greedy method topic, we will discuss about each and every application clearly. So let me explain the pseudo code of the greedy algorithm. So after that, we will continue with the applications. So pseudo code for greedy algorithm. So let me write the pseudo code. Just I am writing here. Algorithm greedy. So a comma n, a is an array and n is the number of inputs that we are giving. So let us take the solution. A solution is equal to 0 means we are just initializing the solution to 0. Now checking for I is equal to 1 to n, do x should be select a. Means we are selecting the array elements. So whatever the elements that are present in that, so that elements we have to select it, and that should be assigned to x value. And we have to check if the feasible solution is present or not. Feasible solution comma x. Sorry, right? Solution comma x. So this is starting. The solution should be 0, and the item, the first select element in the array. So if feasible solution comma x, then you have to combine that. The solution is equal to union of solution comma x. Finally, you have to return the solution. Return solution. Okay. So this is the pseudocode for the greedy algorithm. So in the next video, we will discuss about the each and every application: finding shortest path, finding minimum spanning tree, job sequencing with the deadline, and fractional knapsack problems. Thank you.